feel like you need to talk about what are the problems that jump into the MSR60 usually is initially. But I know that, of course, I know when you start talking about main thing is, avoiding state and then discussing problems, then of course it's natural to compare with here because that's trying to solve that problem. So then we end up with discussing a lot about here eventually. But I think, I don't know, I think one thing that we could describe in various ways why having this state is causing problems. And then we can, I don't know. Yeah. Maybe it's yeah.
Oh, it's 9:31.
Okay.
Not a lot of people.
Right. So
it's early and it's hard to find. All the way to
go to the side. It's hard to avoid really, but it's okay. Hello.
That's quite another Good morning.
Good morning. Hey, how are you? Good. Instead of Starbucks nowadays, it's coffee. The coffee machine in our hotel was broken this morning, so there was no coffee to wake up. How do you start your day without coffee?
I can introduce you to my colleague here, and she was yesterday in the whole way home bitching about how where she got at 6:20 in the morning a coffee.
In this meeting or in a few days, what we call it.
Yeah, I think
the space.
I
you
think
want
that
to
would be
in,
appropriate.
Why would you be awake?
Because we have to word that very good.
Yeah.
There's still different,
But once you've
We
done
could
that,
get a flood of drafts.
yeah. But once you've done that, I feel like we can invite people and hopefully if we have written it properly, we can say okay, this is good and this maybe we don't want because of this and this.
Yeah.
But try to be upfront with what we.
Okay. I think that's fair.
What do you do?
So how do we do this again?
So I share, I'll take care of minutes.
Yeah.
And we'll drive it from here and you go.
Yeah.
And we're about time, so we should probably get started.
Wonder how many people they have online.
Yeah, we do. You can join too and see. Oh, actually, I'll try to join.
I'll take that one.
So you can see the queue on my phone. Yeah, we need to keep an eye on. Maybe I can do that.
Vienna.
Do we see it there?
No, it was just the.
Okay, we see the queue at least over there.
Oh, right.
But yeah, no, I can certainly do that here.
Yeah, I'll log in this computer too, so we can.
Yeah, let me do it here.
Time to change the picture.
It is time, you're right. Well, especially because I have 3 grandkids now, so I got to add another one in there.
It looks like you just changed the number on the top, 114 to 115, nothing else.
That's all we did. Exactly. And maybe we don't need the pictures anymore, actually, since we're meeting in person.
Yeah. Okay, let me try to bring. I'm not online.
Yeah.
Do you have it? Right?
Do you have what?
No, the deco.
Oh, I haven't done it on this yet. No.
This thing is suddenly.
Oh, that's a good idea.
Server unreachable.
Are you supposed to take a picture of that? Is that how that works?
Oh yeah, outside, yeah. The QR code, yeah. Oh yeah, I see that there too. Right. Okay. Yeah, I already did it, but yeah, I'll do it again. So.
Oh, I see.
Yeah. Yes, but the whole question was able to do anything. It's not. Filming problem or something, right? But they didn't know who it was. When they asked, I guess the TV guys, so it's fine. So that's what I mean. Sure.
Yeah, it's not working.
Yeah, I did it, but then it kicked me out, so I gotta log back in. Hold on.
Okay. Try again.
I'm not gonna do that again because it kicked me out, but I'm gonna just do this.
But we got the slides on that thing, right?
Right here. This is where they're now sharing. We can start.
Okay.
Are you also taking over
Okay.
Yeah, go ahead.
Yeah.
It's all you.
Just keep an eye on the queue over there. Yeah. All right, everyone. Welcome to PIM. Might be our shortest meeting in a long time. I mean, smallest meeting. Not sure how many people we have online right now. So I hope you all have signed the blue sheets, or, well, rather scan the QR code, or register online. So note well. Let's see. I guess you need to drive that. Yeah, you should all have read the note well. Nothing new, I think. Then we have the agenda. So yeah, we'll go through some working group status first, and then we have PIM Light that we had before, and then there's some various new presentations. Any comments on the agenda? All right. Okay, for the working group status, so we have made some progress, a couple of new RFCs since last time. So you have the Young model has been published, and some IGMP MLD extensions been published. And yeah, at the bottom here, we have 3 drafts that we have requested publication for. A start packing needs a revised draft. We got some good comments there. And the other 2 are in the queue. For the DR improvement and backup DR, not really making much progress there. Mankamna.
Yeah, Mankamna Cisco Systems. So PIM Bider, it is not Bider, BDR. It is under progress right now, and I think the new version I'll be publishing in next few weeks, and then that should make progress.
Okay.
Yeah.
So by the way, we going forwards, we're trying to have shepherds for all our working group documents, and ideally at the time of adoption, we think we should try to have a shepherd, so the shepherd can help, make sure that the authors are making progress, make sure that discussions in the working group gets incorporated in the document, and so on, and also check if the document is ready for last call. So including the DR drafts, if anyone is interested in being a shepherd, please let us know. So yeah, we probably won't be able to find a shepherd for all our documents right away, but at least when we do our last call, we would like to have a shepherd. So second part of the status, we have a number of documents that are not being discussed today. So we have the IGMP MLD BIS documents. There's like 3 documents related to that here. We can probably do last call on those soon. I'll check with Brian Haberman, who's been working on that, what the status is, if he feels they're done. We just adopted the 3228 BIS that you see near the bottom there. So we did an adoption call. We didn't get much input, and we decided as chairs to adopt it anyway. It's basically just IANA considerations for IGMP, so it's something that we need to do. We want your help to see if it's ready for last call soon. Though we need working group input for last call. Okay, what else? Yeah, for the point-to-point multi-point policy and policy ping. Human, do you have any comments on those, or what do you feel like the status is? Are they almost done, or?
Yeah, there were some discussions on the spring. They wanted us to clarify some stuff on the replication policy, and I think we submitted the clarifications to the spring, and we are just waiting for last call again. That's where it's standing.
Okay, great. Yeah, thanks. Yeah, we also had this Lisp draft that I'm an author. So as an author, I hope it can go to last call soon, but I'll defer to Mike and the working group.
Yeah.
And yeah, also let's see. Yeah, I think that's pretty much what we have for status.
I just got one comment about, going back to Human, sorry, the point-to-multipoint policy ping. If I remember, I need to check my emails again, but I think I remember the spring chairs telling Stig and I to hold off progressing these until the replication segment draft in spring progresses. Is that true?
Yeah, I have to apologize. I was running around trying to find my way through the staircase, so my mind was a little bit foggy here. So the comments that I gave was for the point-to-multipoint policy draft in PIM. So there is a ping, and then there is a policy itself.
Right.
So my comments with regard to the point-to-multipoint policy. With regard to the ping, last I sent out, I did some modifications to the draft. I did send the email to the MPLS working group because they had some comments to ensure that they're okay with the changes. And I did ask for an early adoption, early allocation of INAA sub-TLV, which I never got any response for that.
Okay.
But I did trigger all this stuff on the working groups, but so far I have not got any response. I would imagine if we can get that early allocation of the sub-TLV, that would generate some response from MPLS working group, perhaps.
Okay, so if you think it could help, Stig and I maybe could help, maybe ask the MPLS chairs to help us.
I would definitely appreciate that.
Help
Yeah,
that
if
along.
we
Okay,
could.
why don't we
Yeah.
put that as an action for
I
us?
appreciate it. Thank you very
Okay,
much.
We'll do that. And I think you're right. I think that's it.
Yeah. All right, so that was the status. Any comments, thoughts on that? But yeah, if you might be interested in shepherding a document, please get in touch with us. Otherwise, we might start getting in touch with, I guess, various participants and see if they can please help out. But anyone would be welcome to shepherd. It's a good way to learn about the IETF process. Okay, so then I guess Human is first with the PIM light.
Can you try to log in? So you can see.
Okay, so I think the draft was adopted by the working group. So thank you for very much for that. We had some very good feedback from Sandy and Tanmoy from Nokia. So I tried to summarize all these feedback in these slides to see what other work needs to be done. Any other, obviously, feedback is greatly appreciated so we can push this through the last call and maybe start looking at because so everybody is aware of this draft. One of the ties that it has is in the beer side for PIM signaling over a beer domain. And this is how it was born. So any extra comments that can come along to push this draft through would be greatly appreciated. Next slide, please. All right, so first comment was that let's make sure that it's very clear that which message types we are going to support. So looking at NA, which I always have a hard time saying it. But anyway, there are 12 message types, it seems like, for PIM, and we only going to support the message type 3, which is the join and the prune. And basically, the trick here is that most of this message type, you need to have a PIM adjacency via PIM hellos before the PIM router accept the message. Most of these 12 message types, for that matter. And one of the exceptions for the PIM Lite interface is that you do not need to have this PIM adjacency and back and forth of the hello messages for the router to accept the PIM join and prune message type 3. So that was one thing that we clarified, crystal clear, that there is no other message type that is supported. The second thing was PIM sparse mode. Again, just because there's no hello adjacencies, that means that all the goodies for the PIM SM need to be within the PIM domain. What that means is that you are not going to be able to have a RP or a DR on the other side of the PIM Lite domain. So if there are two PIM domains that are attached through a PIM Lite domain, you cannot mix and match your RPs and designated router over the PIM Lite domain. So we did a clarification on that one. We also put a bunch of text around the fact that the lack of hello message means to PIM Lite routers. And one of the things was the join attribute that we might get in some of the join messages. Obviously, there is, I guess there's a flag. I can't remember quite well. Maybe the experts know better than I do. Or there was a sub-TLV that was communicated in the hello message saying that the router supports the join attribute. With the lack of the hello message, basically it comes down to the fact that if the software on the router does support join attributes, they need to be able to process it. If they don't, then they won't process it. And the last but not least is the DR selection. Again, obviously that needs the hello message, and with PIM Lite, the DR selection needs to be within the PIM domain. It cannot happen over the PIM Lite interfaces or across PIM Lite routers to do that DR selection. Next slide, please. So with regard to the failures of the PIM Lite interface, today, usually when the hello adjacency goes down, we withdraw a bunch of multicast routes from the routing table. In this case, we are kind of suggesting that there could be other type of protocols that can be used to detect that a PIM Lite interface has gone down. As an example, if you have a PIM Lite interface over a layer 2 network where they are multi-hop away from each other, then you can use a protocol like BFD as an example to ensure that there is connectivity on your PIM Lite interface. And if BFD goes down, then that interface is withdrawn from the multicast route, and that OIF is erased from the multicast route. And this will kind of manage the traffic, the downstream traffic going out of the multicast route. So these are all the stuff that we added to the draft. Again, if there are some other comments.
Tolles Eckert. So I would really like to see that we don't use standard PIM, but that this all would be running over TCP, RFC 6559 port, right? Because we've seen, especially when this is used together with beer, we're supposed to be able to much easier support really large amount of state, right? Because the state isn't in the core anymore, but we're doing egress to ingress PE signaling. In all of the large-scale multicast deployments that I had was always the problem of how to get the reliable big burst under reconvergence, right? So you're sending, 10,000s of PIM joins or PIM leaves, right? So it's just terrible, right? I mean, everybody, you know, as a vendor is making his mark for trying to make that work well, and then we finally gave in and said, okay, let's have what we did with MLDP, why people were using BGP as one of the factors, and so when we're now redoing PIM, can we please, you know, pick up our own stuff, which was simply, you know, use it over TCP. And then here, the simplification, and I think that should make using TCP, as we defined in 6559, even a lot less difficult.
Okay, yeah, I appreciate that. Just taking a step back, again, I want to remind how this thing was born. This thing was born, as you know, through the beer, right? And some of the ideas we were toying around on the beer side was that we made it very clear on the beer side that these joins and prunes are only being used for signaling. They are not something that are part of the PIN protocol. And I think at that point of time, the decision was made between some parties that we need to grab the PIM and kind of water it down to become this draft.
That's
So
fine.
I have no issue with going over TCP, but then that definitely going to change the message type of the join and the prunes to be over TCP, right? So
I don't remember exactly what we did in 6559. I need to remember that as well. I thought it is pretty much, you know, the PIM messages without any changes.
Okay.
And just, you know, the problem of the hellos, which I guess we're not going to have anyhow, and the discovery. So, just because it's kind of overlay use doesn't change the problem of the bursty behavior, which is that we're triggering all these join when there's a route change, right? And that can result in thousands of messages. And TCP nicely takes care of that in reliable doing that. Whereas in all the implementations, you need to start having really large buffers, which you otherwise don't want to buffer all these messages, or you're going to have to wait for the 60 seconds to resend it and all the crap that, you know, the datagram architecture of PIM had given us.
Okay, I need to read that draft. Honestly, I haven't read it, so I'm not aware of. Okay.
So on Common Cisco systems, so just to give update, with respect to this particular draft, I think it is completely agnostic to whether we do it over TCP or UDP. So whatever spec we are defining in this draft, that is more to clarify the base PIM behavior, where we always wanted that hellos are coming before even we could do any signaling over that interface.
No, and hopefully it is exactly that way, but then I think we should still have a PIM light implementations must support and default to port, right, to 6559, right, so that we finally get a good reason to get port deployed, right? Port being PIM over TCP, right? So that was the marketing name that we gave it, right? So there's no reason to say we should continue to have PIM datagram as the default for something like this.
Okay, I'll read that draft and I'll open up a conversation.
6659. I think that's the wrong number.
6559.
6659.
6559.
6559. Alberto and I running just a process observation. I know that Sandy did the adoption call. Please reflect that in the data tracker. List her as the shepherd, make her a delegate in the working group so she can push all the buttons. This is because both the chairs are authors in this draft. So, you know, we need to make sure that everything looks correctly. So please just make sure that everyone knows that it's Sandy, the one who's driving everything here.
Next slide, please. Yeah, so I think we covered this slide too. I was looking for comments and stuff like that. So yeah, that's all there.
Okay.
Thank you.
Thank you. Are you on, Nate?
Yes, can you hear me?
Yes, we can hear you good.
Great.
Can you see the slide? Can you see the slides?
I can.
Perfect. Great. You're on. I'll flip the slides for you.
All right, thanks. Good morning, everybody. So just an intro slide, and this is a link to the draft document that we have out there currently. Go ahead and flip. So just to kind of go through the problem that we're looking at here again, this is primarily for boat networks, and these are kind of characterized by everything is on a single subnet. We have displays and sensors and infrastructure devices all kind of connected with each other. Typically, there's no internet connection available to these devices, and the problem we're trying to face is that in a situation like this, you might have a 1 gigabit sensor on a network with several other lower speed sensors, maybe 100 megabit sensor. And if you have that gigabit sensor streaming multicast data, then a standard switch will output that multicast data and overwhelm the link to that 100 megabit sensor there. So go ahead and flip. So the solution here is to use multicast snooping to prevent those streams from going out to the 100 megabit sensor there. And that causes the switch to only forward the packets to devices on ports that request them. Go ahead and flip. So kind of a review of some of the multicast or some of the IPv6 addresses that will kind of build up to the problem that we're facing with this. Based off of RFC 4291, this is the definition of a unicast address, and you'll see that the least significant 64 bits is known as the interface ID or IID. Flip. So to build up a multicast address over time, this has kind of evolved, starting with 1884 and 4291, and then from there you have kind of a definition of the unicast prefix-based multicast address, where you've got the 64-bit network prefix there, and a group ID is the least significant 32 bits, and then finally RFC 4489 provides a mechanism for generating a link-scoped IPv6 multicast address. So basically, any link local IP address comes with a block of multicast addresses that it can assign based off of its link local address. So based off of this, that 64 bits from the link local address goes into the network prefix there, kind of that middle 64 bits, and then the least significant 32 bits are the group ID. Next slide. So for the group IDs, these are assigned based off of RFC 3307, section 4. 4.1 talks about permanent IPv6 multicast addresses, and there's the range for those. 4.2 talks about the multicast group identifiers allocated by IANA again. There's the range for that. And then 4.3 has a range specific for dynamic multicast addresses from hex 800 all the way through FF. Next slide. So the problem is when you go to transmit these multicast addresses on Ethernet, what can happen is the group ID being in the least significant 32 bits, on Ethernet you only have 48 bits, and so the first 2 octets are 3333, and then the last 4 octets are the least significant 32 bits, which is the group ID there. And so what can happen here is, even though your link scoped IPv6 multicast address is unique, the 128-bit address is unique, when that goes out on Ethernet, if different nodes choose the same group ID, then you end up with different link local addresses with sending the same Ethernet MAC address, and you can get collisions there. Next slide. So we have a number of requirements for the solution here. First, it has to be zero configuration. Most of the customers do not have expertise on network configuration, and they're primarily there to use the products. They don't know much about networking in general. No internet connection. Networks are typically a single subnet. And then we need a unique Ethernet destination address. RFC 4541, which talks about multicast snooping. It had kind of a survey on switch vendors and their products, and based off of that, most switch vendors do not support looking at the IPv6 destination address. They're only looking at the Ethernet address. Furthermore, the switch parts at the desired price point for these products, they do not support source-specific multicast. So what we really need here is a unique destination MAC address for every individual multicast stream on the network. We also need it to be a decentralized solution so that we can avoid a single point of failure, which is common on networks that kind of rely on that they provide safety and operation of a vehicle. So the existing solution for dynamic assignment, MADCAP, discussed in RFC 2730, that relies on a server. So that's a central point of failure, and so we cannot use that directly. And then we also want to provide for multiple streams coming from the same host. So there may be different applications all running on the same host that all need to send. And without some sort of back channel communication, we need to have a solution that will allow them to negotiate with themselves at the same time that they're negotiating with the network. Previously, we talked about ZMAP, ZMAAP, as there was a draft out there that would sought to solve this problem, but that wasn't advanced beyond draft state. So we had talked about kind of resurrecting that, but ultimately decided against that. So go ahead and flip to the next slide. So instead we have a solution that we proposed in this draft up there. And here's kind of an overview of what that solution entails. So if you kind of look at the next 4 bullet points as steps 1 through 4. So we would update that table or that section in RFC 3307. Section 4.3 was specifically for dynamic allocations, and it allocated basically half the range of group IDs to host-based allocations. And so the idea there is to kind of subdivide that further and designate a range specifically for zero configuration allocations. And we'll go into specifics on the next slide. Kind of step 2 would be the application that wants to send a multicast stream would generate a random group ID in the zero configuration range. And then step 3 would be that application uses MDNS, or multicast DNS, to ensure that the group ID is unique. Just a note there that MDNS is a zero configuration technology, and that as part of using MDNS, we would both be probing the multicast DNS records before the initial use, and also continuously monitor those MDNS records in case somebody else decided that they were going to use it and their probing had somehow failed. And then kind of the last step there is that the application uses the group ID to generate the link scoped IPv6 multicast address, and then goes ahead and transmits. So in the next 2 slides, we're going to focus on specifically on that update to RFC 3307 and the use of multicast DNS, the random group ID, and then using the group ID to generate the link scope multicast address is fairly straightforward. Next slide. Okay, so RFC 3307 section 4.3, it specifies kind of 2 ranges. In 4.3.1, it talks about server-based allocations, which would be MADCAP. And then 4.3.2 talks about host-based allocations. And in both cases, they specify the range there, 800 through FFF, for both of those. And the proposal here is to subdivide that and say half of that, 800 through BFFFF, would be for MADCAP, or server-based allocation. And then to take a range C0 through CFFF and say that is reserved for an MDNS-based zero configuration algorithm. And D00 through FEFFF, that's reserved for future zero configuration or host-based allocations in case there's other ones in the future. And then something that was kind of left out of RFC 3307 that I think is important to note here is that the range FF00 through FFFF is for solicited node multicast addresses. And so we wouldn't want to allocate those or indicate that those are available for a dynamic allocation, and that should be reflected in the table. Next slide, please. So kind of 2 slides here talking about how we would use MDNS to ensure that group ID is unique. First, a note on how DNS uses PTR records to perform reverse lookups, and we see the same pattern in MDNS as well. So RFC 8501 has these examples here. So if you want to provide a reverse lookup record for the IP address 192.0.2.1, you create a PTR record with the name 1.2.0.192.in-adder.arpa, and that in-adder.arpa is specifically for IPv4 addresses. And note that the octets are listed there in reverse order, least significant octet first. Similarly, when you go to IPv6, you're taking your IPv6 address and you're taking each hexadecimal number and putting it there, starting with the least significant and putting a dot in between, and then you end with IP6.arpa. So the proposal uses a PTR record for layer 2 addresses. And this specifically focuses on Ethernet addresses. If there are other layer 2 technologies that we need to support, we would need to have separate ARPA domains for those. But in this case, the example being your MAC address there, which is a IPv6 multicast address because it starts with 3333. That again takes the least significant hex digit and separates it by dots and ends with eth-adder.arpa. So that eth-adder is a new allocation in the ARPA reserve table. So once the application, it generates its random group ID and it determines the Ethernet address from there, and it then probes the network for a PTR record with that name. And it uses the MDNS probing algorithm described in RFC, in the multicast DNS RFC in section 8.1. It sets up a continuous query for that PTR record. And continuous query means that if anybody else also generates that and starts advertising it, then your multicast DNS or MDNS responder software will let you know. Next slide, please. So if the programming algorithm completes without any conflict, then the application begins advertising its own PTR record using that name. And the format of the PTR records, there's a PTR DNAME field in there, and that would be the device's host name, a colon, and the source port of the multicast stream. So there's an example there, myhost.local, colon 56296. And just wanted to note there that the reason that the source port is integrated in this manner, that allows for multiple applications to be on the same host. And so if you had 2 applications that on the same host that happen to generate the same PTR record, there would be no way to know that without including that source port there. This way, your multicast software will tell you, oh, hey, I found this record, and it's using the same source port that you're advertising, therefore it is you and not somebody else on the same host. And then the existing draft basically has a recommendation that the application should retain that group ID value in long-term storage and use it the next time the multicast stream is transmitted. So this, when you first set up a network, there may be some conflicts that occur. but by storing the group ID value in long-term storage and reusing it next time, that basically ensures that you're only going to run into that conflict the first time the network is started up, or anytime you might add a new device to the network. After that, the conflicts shouldn't happen, and your network won't have to go through that that conflict resolution process where you would have to generate a new group ID, probe again, and transmit or register that PTR record. Next slide. So that's basically it. Wanted to open up for any questions.
Hi, Nate. This is Dino. I have a question. You said the source could have multiple applications running. Can the receiver have multiple applications running as well?
Yes.
Okay. And could you go to the last slide? You said you have to advertise the port number. You probably should advertise the port number with the multicast address so you know which port to use with which multicast address. Because there could, a source that's running multiple applications needs to use multiple ports, correct? Or are you going to use
correct.
the same, or are you going to use the same port with multiple different addresses?
So in this case, are you meaning like the destination port or the source port?
There's 56296 on this slide. However you intend to use that, what are you using that for? A destination port or a source port, or both source and destination are the same port?
So the source and destination are going to be different ports. The example or the record here contains the source port of the stream.
And then you're going to use a well-known destination port.
That's correct. Yeah.
Okay. So, so answer my question then. If the source is running two applications, 56296 is being run for one application. Are you advertising another port for the other application?
Right. So what we would hope to see here is that the two different applications generate different group IDs, and so the name of the PTR record is going to be different. It would have a different set of different address .eth-adder.arpa would be the name of the record, and then the PTRD name would also be different. The host name would be the same, but the source port.
That's fine, but that means you're going to use the same source and destination port for the different streams. I don't think you can open up a socket to do that. I think you have to have a different source port per stream.
Well, yes, that's correct. So in this
Okay.
case, if you have two different applications, the record name would be different because the destination address would be different, and the source port would also be different.
Okay, so there's a list of these myhost.local port numbers that'll be advertised, right?
Right. It's
And
less
we're-
about advertising those and more about advertising the address.
Okay, then why do you have to advertise the port? If the other site's just going to listen on the well-known port, then you don't need to advertise the source port.
Right.
We can
So
take-
what can it?
I was going to say we
let's
could
say
take it
you-
off.
Okay. Yeah, we can see if there's any other questions, and if not, I'll answer that one.
Yeah, let's just dig. So one thing about the column, I don't think that's allowed in a domain name. I could be wrong, but yeah, I'm not so sure if you can use that. But otherwise, so we're assuming that any application using a group ID in this range would use this scheme, right?
That's right.
Yeah, okay. So yeah, I'm not sure what the madcap status is, if it's being used for IPv6 today, but we may have to update, madcap RFC or something like that, since we are constraining, what range they can use. We probably need some review of this, I think, from people working on MDNS or possibly, not sure, some IPv6 experts as well. But let's sure that it works well for us, that we have a design that works for your use case, first of all. Okay, that's my comments. Alvaro?
Alvaro Tana, Routing ED. I was going to try and do some of the same points that Stig is making about what you're doing in this draft. If I understood correctly, you're not really changing MDNS. You're using MDNS for
That's correct.
distribution and all this stuff. And then the other thing we're doing here is you're changing the ranges in 33 whatever, right?
Yeah,
Okay.
3307.
So, it sounds like the working group in general, even though I don't think have asked for adoption, thinks that this is, a fine solution. There's, some questions that you can, maybe address or whatever. The question that I have, not for you, but for the chairs mostly, and is, should we do this work? Meaning, this is really an application of MDNS and an update of an IANA registry. So what I would probably want to ask you guys, Stig and Mike, is to figure out with probably I think it's the DNSSD working group that does MDNS, and maybe 6-man to figure out what do we do, right?
Yeah.
I mean, it's probably okay for us to process this document since it's a multicast application in the end, but we'll need to coordinate with them. The RC, that 3307, was produced by a working group that doesn't exist anymore. And so we need to figure out who still owns that, and how can we really modify the registry if 6-man or whoever the IPv6 guys who are going to own this are okay with that, and how do we get to that? So we'll need a lot of coordination with those other working groups. It might be that, given that we're saying that this is a good multicast solution, that we can, let MDNS or the NSSD, for example, process the document. So we need to figure that out. And the less overhead that Nate can see, the better. So you guys do all the work, and let me know if you need anything from me, and I'll be happy to help. Thanks.
Yeah, I think this is Mike McBride. Stig's going to have to drive that part because I'm on the draft and I think it's a good idea. So Stig will drive that. Brian Haberman is the one and only author of 3307. So I don't see him on the queue, but we'll make sure that he's involved in this as well. And last comment is Magma, that working group you were talking about, that no longer exists?
So 3307 was done in Malloc,
Malloc.
which
Okay.
sounded like multicast allocation or something,
Yeah,
which
yeah.
I just looked and it happened to be in the transport area for some reason.
Okay.
I don't know why. So we probably could ask Brian, because it turns out that the registries are expert review registries. I looked at the IANA page and there's no expert assigned. I would have assumed that maybe it would have been Brian since he wrote the RFC. So we need to probably talk to also Eric Klein, both Erics, Eric Klein and Eric Vink, to figure out, because they're probably going to have to get an expert, which would be great if it was Brian, because he's already, maybe familiar with this and has at least in the draft. And all he needs to do is approve if it's okay for the range to be different, right? Not the application itself. So, I mean, this is just a bunch of different parts that we don't control that we need to just make sure that they're okay.
Right. Yeah, I think we also may have to look at MadCap, other implementations. Are they today using that larger range? But yeah, I'll look into that and contact people. Yeah, thanks.
So to respond to your comment, we live in a decentralized world now, and we need unique group allocation for applications in general. The problem needs to be solved. It turns out this solution is solving it only for a layer 2 network. I think we need to generalize it and do it for layer 3 as well. So when you talk about it in that context, then this working group should work on it.
Yeah. Yes, Stig again. Yeah, I agree, and that's actually one of my concerns with this. Maybe is if you come up with something like site local or more global, you need to make sure that they don't conflict with each other. I'm also wondering today if someone uses a group address in this range just by chance or whatever, how do we gracefully, detect that, or how does it work?
Well, that's
Yeah.
why he wants to do an allocation that's dedicated to this, so
Right.
nobody else should use it. Just like Nate is
Yeah.
staying away from the existing
Yeah,
allocations.
that also means that, someone deploying an app or just choosing a random address, they need to be aware that they should stay away from this range or.
Yeah, I have the same concern you do, because this solution is using multicast to allocate a multicast
Right.
address.
Yeah.
And the reason it works is because it's on layer 2.
Right. But one thing I saw in a draft that will help I saw is that, if an application receives packets to this group that is not coming from the correct source, then you should stop using it. So that should help. Okay.
Thomas Eckert. Yeah, also thank you very much for the draft. And I also don't know yet what to think about the technical solution, but as much as I likely may also run into issues of how good it is in the end, right? I mean, this is not the first time that the best thing we were able to actually manage to get done isn't the next best thing we would like to see. And, in doubt, I would rather err on the side of getting something useful deployed than waiting out for something much better we can't figure out.
All right. Okay. Thanks. Yeah. So I think I'll reach out to Brian and potentially some other people and get some input. And I think in the working group, we would like you all to read this and see if you like the idea, see if you can come up with something better or improvements to this. So yeah, I kind of wonder how many people have read this. I don't think we're ready to adopt yet, but kind of curious just if most of you have read it or if it's mostly new to the working group. I guess we need to do a poll if you want to check that. Yeah. Yeah, so just to get some quick idea, I just want to do a quick poll to see how many people have read this document. Yeah, I think we're okay then. We don't need to know exact numbers, but so far I see 6 people have read it and 6 people have not read it. So that's fairly good. Yeah, so please read this document if you're interested, and any feedback on the list would be great. And in the meantime, before the next meeting, I'll reach out to some external people and see what we can do. All right.
How can I get that off the screen?
Oh, I thought I did. Thought I canceled it, but. Oh wait, I just need to go back. I think you just need to go back to, I don't know.
I don't know either. Yeah, how do we get that freaking off? Yeah, I'm gonna stop sharing and then.
Okay.
So that's stuck on there. That's not me anymore.
Right, that's what I was thinking. What?
Is your poll closed?
Yeah, let me see.
Try escape, maybe?
It says reopen, but this is on.
That's
It's not on your
that's not part of this.
computer.
It's part of this, but I don't see it on that screen. And it says don't touch.
You can try to reopen and close it
Yeah,
again.
try that.
Or maybe I did dismiss. Let me do end session. Okay, I think that's good. Okay, very good. Okay.
What is it, end session? Is that what you had to do?
Yeah, I think dismiss is just get it off my screen, but end session is actually ending the poll.
Okay, thank you, Nate. Appreciate your time. Go to bed. It's late. And Hongji? Is he online or is he in the?
Hi, Mike. Can you
Hi.
hear me?
Yep, go ahead.
Okay. Hello, everyone. I'm Hongji from Ericsson. Now today let me introduce a new individual draft about EVPN multicast YANG model. Next, please. This is the first version for presentation, and the effort is from multicast YANG design team. We are from Ericsson, Cisco, IBM, China Mobile, and Juniper. Next, please. Now let me introduce some background about this draft. There is a draft IETF base EVPN YANG. It defines IETF YANG data model for Ethernet VPN services. It covers the following 5 types of EVPN route defined in RFC 7432 and RFC 9136. The type 1 is the Ethernet auto discovery route. Type 2, the MAC IP advertisement route. Type 3, the inclusive multicast Ethernet type route. The abbreviation is the IMAN route. Type 4 is the Ethernet segment route. Type 5, the IP prefix route. Next, please. This year, the RFC 9251 was published maybe in June this year. In this RFC document describes the IGMP MLD proxy for EVPN. It defines 3 new EVPN route types to carry the IGMP or MMD membership reports. So they are the type 6, from type 6 to type 7 to type 8. The type 6 is the selective multicast Ethernet type route. The abbreviation is the SMART route. The purpose of this route is to distribute the host intent to receive the multicast traffic for certain multicast group. The type 7 is the multicast membership report sync route, and type 8 is the multicast leave sync route. The type 7 and 8 are optional, and they are used to optimize the multicast access segment. Currently, these types of routes haven't been covered in any YANG data model. So we defined the new IETF EVPN multicast YANG data model. It extends the IETF EVPN data model to configure and show the EVPN multicast service. Next, please. Here is the structure. We augment the EVPN instance and add 3 new attributes about the new 3 EVPN routes. The first one, the cell multicast advertisement. If it is enabled, the BGP could publish the SMART route. And next, the EVPN IGMP proxy. If it is enabled, it will trigger a MS root update with the multicast flags extended community and the IGMP proxy bit is set. It means the IGMP proxy for EVPN is enabled. The EVPN MMLD proxy is similar as the above one. If it is enabled, it will trigger ML root update, and that means the MLD proxy for EVPN is set. Next, please. And this is the details about the 3 new EVPN routes, and we augment the EVPN instance routes slash routes. And the first block is the smart route, the information about the smart route. And the route RD and RT information are similar as other EVPN routes. And the Ethernet tag is used to identify a broadcast domain. And the second block is the multicast is a type 7 type 7 route. And the Ethernet segment identifier is the ESI information. The last block is the multicast leave sync route. Most of the attributes are similar as the multicast membership report sync route. The max response time. The max response time is the value to be used while sending a query as defined in the IGMP protocol. Here, all the EVPN rules are read-only. Next, please. Okay, this is the draft for this new year model. We will welcome more comments. Thank you.
Yeah, hi, this is Stig here. So the EVPN BGP routes, what I should say that you are, describing here, they are all specified in BEST, right?
Yes.
So have you tried to get this presented in the BEST working group?
I thought that this draft is used to handle the EVPN multicast service, include the IGMP packets or the MLD packets. So I made the first presentation in our PIM working group. Do you think it's better to make the presentation on the BEST working group?
I would say at least it relies heavily on an RFC from BEST. So yeah, I think it's good to present it there. I guess you have to think about which working group it would fit in, which working group should be the home of the document or owner of the document. But yeah, it's probably good to get it presented there at least. Get input from people in BEST. Yeah, maybe Mankamna has some thoughts on that. Yeah.
Yep, Mankamna Cisco system. So I think you already made that comment that this belongs mostly in BEST, because even though multicast terms being used, the whole EVPN infrastructure with BGP, it is being done in the BEST itself. And on top of that, the base EVPN Yang model itself are on hold for now in BEST. So I don't think it may be a good idea to do something which is beyond the base EVPN itself. So it has to be done either along with the base EVPN or after that.
So is this model somehow inheriting or extending parts of the other model, or?
Yes.
I guess so.
Yeah.
Yeah, so I think we can definitely talk to the BEST chairs, but yeah, it sounds like
It sounds like one of the best chairs anyway thinks it should be done at best, right? Is that what you just said? This, you think that this draft that was just presented should be in best? Yes, okay. Okay. That kind of makes it easier.
But he's not on the chair. He's not on the chairs.
He's not. Oh. Okay.
Secretary.
Oh, okay, okay. All right, so Stig and I will talk, we'll reach out to all the chairs and we'll help you out, Hongji, to know where to take this.
Okay, thank you.
Thank you.
Okay.
Is Lenny on?
Okay, let me see.
I am.
Very good, thank you, Lenny.
Do you want me to,
Just tell me
do you
when
want
to
me to
flip.
all the slides or do you want me to just tell you to advance?
Just tell me when to flip.
Okay. How's my audio? Can you hear me okay?
Yeah, it's great.
All right. So this is a draft that I presented in MOPS on Monday. Also going to present this in MBOND. There seemed to be support in MOPS to adopt this on Monday. Looked pretty good in preliminary polling, but also going to present in MBOND in case that's another relevant working group on this. But wanted to share this with this group because this TreeDN is a model that that utilizes the protocols that PIM has been developing, and some protocols that PIM has been developing, and wanted to share this with folks in PIM to make people aware and get some feedback. So TreeDN is it's a model for it's a tree-based CDN model that's optimized for live streaming to mass audiences. And the problem that we're trying to solve with TreeDN is with live audience sizes beginning to approach critical mass, as combined with increasing bit rates for things like 4K, 8K, and augmented reality. Are we at an inflection point for the amount of resources that live streaming is consuming on the network? The perfect example of the most recent example of this is Thursday Night Football, American football. The NFL is for the first time being exclusively live streamed by Amazon Prime. That started about 2 months ago, and the first night of that, Amazon announced there's about over 11 million streams, and this is pretty high interest. NFL football is kind of like the national religion. It's the closest thing to a national religion that there is in the United States. So given increasing audience sizes and increasing bit rates, are we at an inflection point now? If not now, will we ever be? And if the answer to either of these questions is yes, the question is what should we do about it? One thing to keep in mind is that live streaming is not the same as on-demand streaming. There are some people who have kind of suggested, what's the difference? Streaming is streaming. If people aren't watching a live stream, they'd probably just be watching a Netflix movie. So it's and that's been working just fine. The key thing to keep in mind is that live stream is different, has different requirements. The most notable is expectations for latency. You can't have, for things like sporting events, you want the latency budget is kind of, the goal is about 10 seconds. That kind of matches what traditional broadcast television has been. If you go much longer than that, you run the risk that you end up receiving, you could get a text message from your friend about the game-winning score. a minute before it happens, a minute before you see it, or you hear your neighbors or the bar across the street, everybody's cheering for something that you end up seeing a minute later. And if you want to do things like micro betting or in-game betting, where you can actually bet on, will what's the next pitch going to be like, or will the team score in this possession? The latency requirements are even far lower for that. Another key thing to keep in mind is join rates are vastly different. If you look at the graphs for on-demand streaming, it's predictable. It looks about the same every night, and it's fairly smooth. Kind of increases, around 8 o'clock and decreases around midnight. When it comes to live streaming events, things like sporting events, it's more like a step function with everybody joining all at the same time. Next slide. In terms of network-based replication, multicast has been around for a while. It's been fairly successful in some places. It's absolutely vital on financial networks, and it's widely used on video distribution networks and VPN service providers. It's a checkbox requirement, and it's also used pretty widely on some enterprise networks. When it comes to internet multicast, not so much. It hasn't been as successful. So it's worth asking, and that's really, what we're talking about here. This is kind of an internet multicast use case, over the top use case. So it's worth looking at, what went wrong with internet multicast. Next slide. So you can get lots of opinions from different folks about what went wrong with internet multicast, but I think that the three biggest ones, three most impactful issues are, the all or nothing problem. And that is every layer 3 hop between source and destination must be multicast enabled. Essentially every interface on every single router and firewall on the internet needs to be running some type of multicast routing protocol in order for it to work. And if any of those links aren't, then multicast won't work, right? I think we're all too familiar with this problem. Likewise, there's the it's too complex problem. Operators have been complaining for decades that multicast is just too difficult to and complex to deploy, troubleshoot, operate, and manage. And then there's the chicken and egg problem. There's no multicast content because there's no multicast audience, and there's no multicast audience because there's no multicast content. So these have been kind of the three big things that have plagued internet multicast. The good news is, this isn't your grandfather's multicast anymore. We have some technologies that have evolved and advanced to address these problems, and we're in pretty good shape that I think the folks in this room might know about, but outside of this room, they're not as well widely understood. Next slide. So TreeDN is tree-based CDNs, and it leverages native and as well as overlay concepts to deliver a service for end users, and it can be delivered regardless of even when certain parts of the network don't support multicast. So there's the native piece. Think of this as on net. This is the part of the network that is multicast enabled. And the key thing, the key component of this is simply SSM. I think we all know what SSM is in this room, but maybe outside of this room again, a lot of people have made up their mind and made decisions about multicast, and it was based on the ASM model. And you hear a lot of opinions are based on things that are no longer relevant or were only relevant 15 years ago with the ASM model. The key benefit of SSM is it vastly simplifies deployment. With SSM, you can get rid of data-driven state creation, RPs, MSDP, PIM register messages, NCAP and DCAP. shared trees, tree switchover, all of these things that contribute the complexity. You know, I'd say over 90% of the complexity of multicast is ASM. You take away when you move to SSM, you eliminate the vast bulk of that complexity. So that kind of addresses the it's too complex problem. In terms of SSM, it can be realized. It's typically realized with PIM SSM, but could also, you know, in any protocol, control plane protocol or data plane protocol, whether it be MLDP, GTM, BGP, MVPN, BEER, SRMPLS, could be leveraged to support SSM. So that's the native piece, and then there's the overlay, and the key component of the overlay is AMT, which dynamically builds tunnels to end hosts or even application layer to hop over the unicast only parts of the network. It's most valuable at the last mile, where the last mile doesn't support multicast. You can just tunnel over that part. But it could be, in theory, be used to support middle mile or first mile problems. Pretty much anywhere where multicast isn't natively available, AMT can provide that bridge. On the last mile, it's a nice benefit is it simplifies. You can avoid some of the Wi-Fi, the issues of Wi-Fi and multicast. I think Mike, you know this well, and there's been some work on this, and as well as other in-home issues that might make multicast challenging. So AMT kind of hops over those places, and you know, from a service provider perspective, you just push it out to your border, and then, you know, tunnel it, and send it to the end user, and they take care of it from there. So the key thing about these overlays, and, you know, specifically AMT, is it solves the all or nothing problem. Now we can hop over those parts of the network that don't support multicast. Also solves the chicken and egg problem, because in theory, with AMT, in theory, any host on the internet can be a potential audience member. Talked about AMT, but any overlay networking technology that, you know, enables multicast could be leveraged, and Lisp is a good example. So AMT is probably the most common and use case, just because it was designed to solve this last mile problem, and it can be integrated into the host or the app or even a home gateway. But Lisp, you know, has some nice benefits. It can help on the sourcing side, which is something that AMT doesn't support. Another nice, really, you know, benefit is incremental deployment. This treaty, you know, the TreatyN model supports this concept of incremental deployment, which is something that hasn't been available in the past with multicast technologies. It's been kind of, like I said, an all or nothing problem. Next slide. So here's kind of like a 30,000-foot view of what TreatyN looks like, you know, within the broader internet. So you see kind of the big I internet. Within that is, you know, the multicast enabled portion of the network. Call this the M-bone, multicast backbone. And this is where a TreatyN provider can take content from a content provider, multicast content, and deliver it natively to native receivers, or to off-net receivers. Those are receivers not connected to the multicast infrastructure that are on unicast-only networks. We use AMT to tunnel it. So TreatyN isn't really anything new. It's kind of the synthesis of old things, but put together in a way that can deliver and derive the service. So you get, you know, TreatyN is really SSM plus AMT. Stig, you have a question?
Yeah, you were saying that this is new, right? But this is kind of what we've been telling people, that they can deploy this for quite some time now. But I guess we don't have a document that explains it all in one place.
Yeah, there's really nothing new here from technological standpoint. It's the combination of really SSM and AMT to describe essentially a CDN architecture.
Right.
And yeah, and the next few slides kind of explain why now, why give this a name.
Okay, sure. But yeah, it might help us reach the right audience, hopefully. One thing I just want to add is you don't have it here, but of course, often you might have a content provider and static tunnels to various other networks and stuff like that. So what is shown like content provider here could potentially be, some router receiving multicast from some other provider that is the actual content provider, I guess.
Yep. Yeah, I mean, you could substitute just source, the content source.
Sure. Okay, thanks.
Dina?
Hey, Lenny. Yeah, I want to echo that comment from Stig because we have an AMT document that describes the protocol, but we need something like a last mile multicast document that basically says that this slide can be done. And it's basically everything that you've been saying for quite a long time is, the sources are inside the native multicast cloud and you reach receivers that are inside of there or receivers that can attach using the AMT gateway. So it's like we need some kind of usage document. Maybe that's an MBOND and not here, I don't know. But it's a deployment document of some sort. And I think it could be rather short too.
Yeah, and that could also be included in the lessons learned draft that will be discussed next.
I think that's different. One's a historical document and one's a deployment recommendation document.
Oh, okay.
Yeah.
Nils Warnke, Deutsche Telekom. Lenny, two remarks here. Maybe to incorporate also the work that Jake has done for MBOND. Maybe it's also interesting to point out that the content provider could be off-net and connected via the AMT gateway, not relay, gateway service. And the relay could also be pushed out towards an edge cloud or something. Also, if you don't want to incorporate that directly onto the routers. I think with virtual routers and edge computing, this could also be a use case.
Yeah, that's so the document does talk about, overlay. It speaks at a high level about overlays and the focus here is on last mile and, to address the off-net receivers, but it does talk about how it can solve the middle mile and first mile problems, which I think Jake's documents have done a good job. So it kind of, in a hand wavy fashion, kind of addresses that at a high level.
Okay, fair point. But the last remark regarding relay in the edge cloud could also be is also about the last mile.
Yeah, so that's an interesting idea, and I would invite you to come to MBOND next, and there's going to be an interesting presentation, kind of an update on the multicast menu that Lauren is going to give, and it kind of graphically illustrated. There's going to be a demo of that, so it's a teaser for MBOND.
Just one real brief comment. So that's a good point that Niels just made, that the source could be off-net, the receivers could be off-net. So it's not just a last mile solution, it's also a first mile solution, and it could be a middle mile solution too, meaning there's no native multicast anywhere. And do we want to, but by having a pure overlay that does it all is yet another example. And you might want to do that just because you may not have multicast. So you want to deliver the IP multicast service via this large content. So all these combinations should be worked in some kind of document.
Yeah, agreed. And one way to think of this is, the overlay is it may not be a destination. I think, it's kind of you bring up a great point. It could start out with, this green network, this green blob in the middle could be really, really small. But over time, as people begin to see more and more value to multicast, it grows. So, ideally, the goal and the most efficient scenario is native, and seeing this grow over time. But the overlays essentially provide that bridge that gets you from the green to the non-green. And that green may be small or it may be big. Right now it's small, but it allows, it's an architecture that kind of gets more and more optimal the bigger the green gets. And it also provides a level of incentive for providers to become more and more green. But you're not, what multicast has always suffered from is you're bounded. The value of multicast is bounded by the size of the green. So if you can, this benefit of incremental deployment makes that green get bigger. ICE.
Yep. Hey, ICE, Arcus. Doing SSM over the internet, I think another deployment hurdle there is the source discovery, right? Because the source needs to be fed into the first hop router, and it has to be known by the application. Are you going to discuss that as well? How to sort of get the source discovery going?
Well, this document prescribes SSM, which says, don't do network-based source discovery. In SSM, source discovery is handled out of band, typically by the application layer. So that's, I think, one of the great lessons learned. And
I'm not suggesting
Mike's thunder.
Yeah, and I'm not suggesting that we do in-band source discovery, because we all know that that's much more complicated. But by punting it to say the application has to do it, that's great. But if they don't, then we cannot do SSM.
Right. Yeah. So this model says do that. Punting to the application layer is, or some type of out-of-band mechanism. Application layer is probably the best, most effective place to do it. But yeah, I mean, that this we narrow the scope and we make the value judgment of, and this has already been done. I mean, there's the RFC. I forget what the RFC is, but essentially interdomain ASM has been deprecated, and it says essentially use SSM. So we're following those guidelines.
Lenny, just a quick point. This is Dino again. With respect to growing this green cloud, like you said, if you started with an overlay to solve the all or nothing problem and head-end replication kind of hits a wall, then providers now have the customers coming out and they have to solve the problem. And so they'll be forced to use the green cloud because it'll scale better. So I think it would naturally come out. Now you want to be able to do this gracefully, but that's how you break the chicken and egg problem as well.
Yeah, exactly. Yep. Okay. Next, so this is the 30,000-foot view. Here's kind of like circling into the green part. So this is a CDN without multicast. There's different models for CDNs. If you hit next, Mike. Yeah, there you go. So there's different models for CDNs, but typically you have these CDN boxes, and you have a source that goes to one of them, and they distribute to the other CDN boxes, and the CDN boxes kind of support local receivers from there. So the benefit of this is, it just works. You don't need multicast routing protocols to get this working. So that's why CDNs are popular. But next slide. This is CDNs with multicast, TDNs. The first thing, hit one more time, Mike. One more. Yeah. So the first thing we do is we replace those CDN boxes with AMT relays. We push them all the way out to the border of the multicast-enabled network, and we send traffic only to receivers that have to relays that have local receivers. So that's one optimization. But the key optimization here, compared to CDNs without multicast, is if these AMT relays are deployed on existing network infrastructure. That is, if you have routers or network devices already in your network that do support AMT relay, and there are a number of platforms from a number of different vendors that do support AMT relays natively, you essentially have a CDN on a chip. So you can, as a service provider, as a service provider, as an operator, deliver this service for essentially zero capex. If it's built into the forwarding plane of the router, you can essentially offer this service at zero capex, as opposed to typically with CDN boxes. It's a rack of x86 servers that have to get racked and powered up and plugged into revenue generating routers, kind of as barnacles. This is something that's actually built into the infrastructure. So it should be, dramatically cheaper, and, indications with folks who've kind of looked at this model is, it could be significantly less expensive to offer this service than traditional CDNs. So that's zero capex. It's just a couple lines of config, and you can even argue zero OpEx because you don't have to plug in boxes that need to be powered and racked and stacked and plugged into routers. Next slide. All right, so key benefits. You get more efficient network utilization, right? This not only for content that's there today, but it's really, the real benefit is it makes possible new content from new contributors. It makes it more viable. So things that we can't imagine, things that don't exist on the internet today. Things, a good example is augmented reality live streaming to mass audiences. What if you could have that experience instead of just watching a game the way we've always watched it on television? What if you could have an AR experience where you feel like you're in the front row, center court, and you could look side to side and see the celebrities sitting next to you, and you can hear them talking, and you can have a real immersive experience. Things that aren't really, could you do that today? Could you have an AR live stream of a sporting event? Maybe that's a 200 meg or maybe 1 gigabit stream, and deliver that to tens of thousands, hundreds of thousands, and perhaps millions of interested receivers. Can the internet do that today? I don't know. If it can, it certainly probably would be really, really expensive. But this is pretty trivial for a multicast enabled world. And it allows service providers to offer a new service, replication as a service. Send us your content, we'll deliver it, we'll push out that replication point to the most efficient point in the network. So like I said, if your existing infrastructure supports multicast, you can deliver this at essentially zero additional cost. The nice part about this is this is an open standards-based architecture that's using widely available and understood protocols. This isn't a proprietary CDN technology that only that is proprietary and doesn't necessarily interoperate amongst between different CDNs. It also has far less coordination required between the content provider and the CDN provider. Some traditional unicast-based CDNs can often have essentially storage requirements, so you have to deal with data storage, protection, in some cases key management. With TreeDN, you're just forwarding packets, so you don't have to deal with those issues when it comes to the interaction between the content provider and the CDN provider. It's just those interactions just happen between the content provider and the end user. The other nice thing is this is a decentralized and democratizing technology. Essentially, decentralizes and democratizes content sourcing. Is it healthy for the internet and society? that only a small handful of companies kind of control nearly all content distribution. This is an architecture that enables us to get back to our decentralized roots for the internet, and potentially enable and reduce the costs and for smaller entities to deliver content without large intermediaries. Next slide. So in terms of use cases, I've spoken mostly about video. That's kind of the sexiest and most obvious use case. But there's more to it than that. It's really, the use case is any multi-destination traffic. This could be audio, could be video, like I've talked about, could be AR, could be telemetry data. I invite you guys also to, here's another teaser, come to M-Bondi, and there's going to be a presentation and a talk from a provider that's actually doing this, and they're delivering, they're doing 3DN for weather satellites, atmospheric weather satellites that are delivering real-time telemetry data to research institutions that are looking at this atmospheric telemetry. So that's a use case, doesn't have to be video. Or it could be large file software updates. This is less sexy, but probably a more acutely painful issue. This is something that Jake has been working on and talked about for years. The idea of like iOS updates, things that need to get pushed out overnight to tens of millions, hundreds of millions of devices, and multi-gigabit files. So that's certainly an applicable use case. Next slide. So to summarize, we may be at a nexus point for live streaming on the internet when it comes to kind of the crossing of supply and demand curves. The demand is being fueled by exploding live stream audience sizes, in the tens of millions now. That wasn't necessarily the case. We have that on a weekly basis right now, and that wasn't the case, prior to 2 months ago. And increasing bit rates, 4K, 8K, and AR. Combine that with the supply. Previously, multicast was complex and difficult, 10, 15 years ago, but we've been working at it, folks in this room and folks in M-Bondi. We've been working to improve and make network-based replication easier and more available than ever. So when you combine those two things, multicast is easier to deploy, easier to operate, and more valuable and useful because it can work out anywhere. Combine that with this new, bursting demand. We're kind of at a, perhaps a nexus point where this model, multicast-based CDNs becomes much more viable, and that's what 3DN is. It describes a CDN model that's optimized to address this the increasing strain that live streaming is putting on the network, not only for the content today, but also enabling new content that we couldn't imagine. In terms of next steps, we're seeking working group adoption. It kind of fits between M-Bondi and MOPS. I think MOPS is probably the better place because there's more expertise on the CDN side, but also going to be talking about this in M-Bondi. So wanted to share it with this group, let people be aware of it, perhaps a little teaser for further conversation in the next slide and the next meeting. But would welcome any feedback and thoughts anybody might have.
Shushan?
Xuesong from Huawei. Hi, Lenny. Thank you for your presentation. I think this is a really very interesting topic. Just very quick to clarification questions for the scenario. The first one is whether the source of the live streaming in this scenario will be very dynamic. I mean, it can be anywhere in the network, and whether it can be a problem for setting up, for example, setting up multi P2MP paths. And another question is whether the receivers will be very dynamic. It also influences the convergence of the multicast tree. It's just for clarification.
Yeah, so yes, you can have ephemeral receivers coming and going. Um, I think that's kind of the nature. This is optimized for over-the-top receivers, so that's certainly a use case. And in terms of sourcing, yes, they can. I mean, that's a feature of this. The sources could be anywhere, and that's the beauty of a decentralized model. Sources can pop up anywhere. You don't necessarily have to go through a handful of the large, content hyperscalers that kind of deliver content today.
Okay, if the source and receivers are all very dynamic, do you think the existing multicast protocol is enough to settle this case?
I sure hope so. We've been working at it for 25, 30 years or so.
Sure.
I mean, that's what PIM does, right?
Yes.
I think that's what it's there for. That's what the multicast routing protocols are there for. The magic of this working group has been to support this kind of dynamicity.
Sure.
I know.
Thank you.
Dino, do you agree?
Well, I wanted to respond. Using the AMT gateways, certainly the receivers could move around quite a bit, and they'll just attach to a new relay. If the relay already has other gateways, then the tree's already built through the native multicast cloud, so there's no joint latency there. From the source's point of view, the vision that Lenny has is let's have the sources in the multicast cloud. So whatever the convergence of a source moving, well, source mobility with multicast hasn't been done that much, and that's something to look at, but the source is pretty much stationary. Now, if the source is coming in through AMT, it's the same thing, is that if it hits a relay that is already using that source address and the tree is built, we're good to go. Likely it's not, because it's coming into a new location. So that means there's kind of an RPF change that goes through to the new relay. So Lenny, I guess the message here, or something for all of us to think about, is as AMT sources and AMT receivers move around, will the tree inside the native multicast cloud have to change? And if it doesn't, it's a wonderful scaling property.
Yeah. Yes, Tiger. Also, if the source address changes, right, the application must somehow figure out some way of distributing or updating what the new source address is, probably.
Yeah, great point, Stig. See, I didn't think that, because I always think in Lisp, and I say the source address never changes. Sorry.
Yeah. So I think this is where Lisp can have a play. 'Cause, to be honest with you, AMT does not support sourcing behind an AMT gateway, and that, not to be mistaken for what the work that Jake has been doing. That's been mostly more middle mile, where you have multicast network separated by a unicast network, and using AMT to kind of tunnel between two multicast islands. When you have a source sitting off net, and the source is perhaps unicast, or the source is on another network, that might be where Lisp is a really good fit, because Lisp has the ability to support multicast sourcing much better than AMT. So I think we can just hand wave and say overlay networking and advances in different overlay network technologies can be used to solve the problem of getting multicast from and to wherever it needs to go, even over points of the network that aren't multicast enabled.
Yeah, good point. So having said that, I mean, all the points that you and Stig made means that if you bring the source in to the multicast cloud via Lisp, then the source address doesn't have to change, so you don't have to change the applications. But as the source moves, it could always attach to the same point of the multicast cloud. So the S, G tree that's built inside the multicast cloud doesn't have to change either. So that's wonderful as well.
Yeah.
Right. Yeah, and to be honest with you, anything's possible, but I don't necessarily see the source address changing much for these use cases. I mean, if you think it through, why would the source address need to change? Usually it's a stationary source, or even if it's a drone, maybe it's hopping around, but in a relatively bounded area. But anyway, sorry, I think I've probably taken up too much
Yeah,
time.
I think we need to move on then, but thanks for a good discussion.
Sure.
Yeah. All right. Yeah, Mike, last one here.
We're going to go the full 2 hours after all. All right. So this past summer, there was a interim, I think it was semantic routing interim, and the chat during that interim got pretty busy with people talking about multicast. And somebody brought up the point that, it'd really be helpful to have a document that kind of just went over the history of multicast to see where we've been, to see why we're at where we are, and maybe to have something about lessons learned. So I reached out to Dino and Lenny, longtime multicasters. I think it's been like 25 years or so ago that I worked at Cisco with Dino. He was a developer and I was a tester of the code that he developed, and a lot of respect for both these guys. And so I just picked their brain. And so I got a lot of feedback from both of them about just some things that we've learned over the last 30 years of multicast development. So we put this together. Admittedly, there's a lot of work that needs to be done if this is a useful document, but that's why we're here. And if this is useful, it maybe either be done here since it talks about protocols or in MBOND. Next slide, Stig, if you can hit that space. Yeah. All right, so this is the background that I just mentioned. We did discuss, the three of us, in the last IETF, came up with this draft. It's not intended to be a BCP, just kind of a historical document to help us understand some of the previous development work, to help us understand the current work. And we're hopeful that this will help people that are not familiar with multicast better understand multicast, because it still amazes me that I talk with people fairly regularly that just say the multicast is just very complicated, to the point that Lenny just discussed in his document. So hopefully this may help. And we do start with DVMRP, one of the first multicast routing protocols, because that's really how it started. We solved some problems with DVMRP and made some design choices. Dino and others made some design choices, at least at Cisco. And we progressed from various different versions of IGMP to where we are today with IGMP v3 and MLD, and then a variety of PIM routing protocols that developed throughout the years. Next slide. So I just chose for this presentation just to give you an idea, if you haven't read the draft, of some of the protocols. There's some that I did include that are in the draft are things like Wi-Fi that Lenny mentioned. We have a document specifically on that talks about challenges of multicast in a Wi-Fi environment where there's no acknowledgements and there's a lot of drops. I didn't get into it was pretty contentious many years ago with the MPLS wars at the time between Cisco and Juniper mostly, with MLTP versus point-to-multipoint RSVTE, and then they all came together. So we included that in the draft. But just with DVMRP, it was a flood improve. It is a flood improve protocol. Good initial solution, but we quickly realized that it just wouldn't scale with higher bit rates. And using the network to discover sources, as Lenny just mentioned, was also something we originally thought would be a good idea. It makes the network more valuable, but discovered to be a bit too intensive. And so we felt that this protocol worked good in small scale development in deployments, but began to suffer in larger multicast environments. So we needed better solutions. So we evolved from DVMRP to some other protocols. Next slide. I just have a couple more. The shared and source tree development work. The shared trees were designed to reduce state. A lot of state discussion over the years. We still have those today. Particularly at a time when memory was scarce and expensive. And shortest path trees were simpler and more optimal, but they consumed more state. We did need to fix the flood and prune protocol that DVMRP had. We did fix it. but didn't provide any explicit signaling from the source to discover them. So the multicast routing protocol discovered the sources using PIM. Switching from one tree shared to the other source was a difficult routing problem that, again, I didn't have to fix, but developers did. And because when you join the source tree, you had to prune that source from the shared tree. So we get into that a little bit in the paper, the draft. Next slide. Lenny already discussed in his document the all or nothing problem with every layer 3 hop between the source and receivers need to support a multicast routing protocol. And that tends to create, and it has a big barrier to deployment. And so as he just described, there's a way that you can use overlay networking, you can use AMT to get over that. And we kind of discussed that as well. So when people ask us about AMT, we are trying to share in this document where we've been to get to the point of why AMT is necessary so they can understand why these automatic tunnels are even something that we created. Next slide. So this is the last slide. So there's so many other protocols. At the beginning of the draft lists them all. I don't know, like 15, 20 protocols. There's many more. But we decided to just focus on the major ones. Again, just we're hopeful that something like this, whether it's adopted or not, will be able to help people just understand the history over the last 30 years. So the question we have is this something that we should work on in the IETF? If it is, should we work on it here in PIM, or do you think MBOD would be better? I'll leave that to you, and that's all I got. And nobody really cares. So, is there anybody in the queue?
Yeah, she's on.
Oh yeah, she's on.
I think this is necessary, especially for anyone who is not familiar with the history. Actually, from my side, when I want to learn something about multicast, I will see PIM and MPS, P2MP, and then beer. A lot of protocols mentioned here, also IGMP and MLD, for sure. A lot of protocols mentioned in the slides I am not familiar with. So I think this is a very good document to make people know what has already happened and what could learn from it. So I think it is a good document.
Thank you.
But I'm sorry, I haven't read it
Okay.
yet. I will try to read it.
Yeah, that's a good point. It does leave us to wonder if we need to include a brief description of all these protocols or not.
So one of the problems we're having in the IETF or history is that I see young designers, developers, and implementers coming up with proposals, and older people are saying, no, that's not going to work. And they say, well, why not? And they say, well, we did that so far long ago. And these young people want to get information in detail about what happens. So we have to document history. Otherwise, we'll repeat the mistakes. So that's just a general comment.
Ryan, is that you? Yeah. Okay.
Yeah, just wanted to echo, would love to see this document produced. Haven't had a chance to read it yet. Intend to read it and give you some feedback. I drift in and out of needing to have multicast proficiency in my role as a operator. My apologies, I didn't announce. Ryan Hoffman from TELUS. So thank you for starting this work. Very valuable work.
Okay, thank you.
Yeah, I also think this is useful, and it might be good to discuss PIM Binder a little bit as well. But basically, yeah, if people just look at all the working group RFCs, they can get lost and they don't know which are the core documents and what the options are. So yeah, I think it's good.
All right. Should you take it to the list, or do you want to ask people right now? For adoption or?
Yeah. I think we can do an adoption call on the list.
Sounds good.
Yeah, we might discuss briefly in MBOD as well, I guess.
True.
What the best home is for this, but yeah, yeah, we'll check with the MBOD as well before we consider adopting it. But at least it seems like there's a fair amount of interest. So yeah.
You have a question, Lenny? Comment?
Just speaking for MBOD, I guess it's really early, so the only hat, I'm not sure which hat I'm speaking with is MBOD chair or author, or the only hat I know that I'm taking off is my Cogent hat because it's really early. But you know, my thoughts would be, if this is lessons about deployment, it probably in operations, then it's MBOD. If it's more lessons about protocol development, it would seem like it would be more PIM. This document, I think, does a little of both. So I think it kind of fits sort of in between both, but to me, I think it's more protocol lessons than deployment lessons. So I think that, you know, given that, I would think that PIM would be the better fit, but you know, I would probably defer to, I would recuse myself from that decision and let Greg make that call for officially for MBOD, but that's just kind of my thoughts in the middle of the night, and what it feels like.
I think documenting history for both of those, the protocol development and deployment, is going to be useful. The question is, should it be put in one spec, different spec? I think there's going to be more people that are going to care about the deployment because there's more operators in the world than developers. So I don't know if we want to make this integrated or separate documents. I have a feeling that the deployment document would be much larger because there's been, and I don't know if there's enough people that could document it accurately, but you know.
Yeah, I think it's whether it's more protocol design or protocol, you know, advice for designing protocols, or if it is for how to deploy. Yeah.
And just before sorry, Alvaro, start to jump in front of you. But the other thing I forgot to mention was this is going to be, we have a little bit of time in MBOD to cover this as well. It's kind of tucked at the end of the meeting, so we may not get to it, but this will be discussed in MBOD.
Alberto, and Future Technologies. Both types sounds interesting. I don't know if history of deployment and why MOSPF failed or whatever is as interesting as how do I take the tools that I have today and deploy them together. So in other words, you know, out of the whatever number of RFCs we have, what are the RFCs that I need and how do I put them together so that I can deploy them to the gas network? And the old ones, the ones that we learned something from, we don't need to talk about those, right? It might be more interesting in having something of how do we move forward. If I'm going to deploy a network, well, you know, what do I do? Not why it failed before. I need to know why it failed before to design a new solution, right? So I don't know. From my point of view, it sounds like the history of protocols is more interesting than the history of deployment. And current deployment is more interesting than current technology, which is already documented.
Niels Warnke, Deutsche Telekom. Just a quick remark to that. I generally tend to agree to you, Alvaro. It's maybe more important, but the discussions that we had in IETF 114 and 115 with the nautical solution for auto configuration of multicast showed that old drafts which have not made it to RFC status were pulled out again because the lessons learned from why they weren't implemented and why we thought it was a bad idea to implement that were not documented. So I think it both has a valid point. If you're looking at implementing new stuff, maybe it's good to find what is the current standards that we should look at, but we should also have the lessons learned documented while we failed doing the other ones, because it's also quite a valid information base.
Yeah, an example of that is DVMRP is in the Cisco toolbox. We want to tell people not to use DVMRP.
All right, thank you.
All right, yeah, that's the end of the meeting. Unless there's anything anyone wants to bring up. All right, thanks everyone. And yeah, please come to MBOMD if you're interested in multicast. I guess that's why you're here too. Yeah, thanks.
Very good, thank you.
Yeah.
2 hours. That's
Yeah.
hilarious.
Well, it's nice to have all that time
Yeah,
for
you don't have to
discussion.
push people.
Yeah.
So,
Yeah.
should we dedeprecate